All right, so today we're going to be out of the textbook for a little bit, and then we're going to jump back into the textbook, then we're going to go out of the textbook. So you will need a separate sheet of paper to take the notes at the beginning and at the end. Okay? So today, I shouldn't say it, yesterday, I think is a better way of saying it. Yesterday, we were estimating what the value of logs were. And we said, yesterday, the big question that we had yesterday was log base 3 of 33. And that's where we started yesterday, bless it, by the way. Okay? We started with that one yesterday. And then we said, well, log base 3 of 33 should fall between log base 3 of 27 and log base 3 of 81. And then we said that means that the value of log base 3 of 33 should be somewhere in that 3.1 to 3.3 range. Okay? We estimated it yesterday at 3.2. We agreed with what was in the test. Everybody good with all that and remembering that from yesterday? Okay? Today, because mathematics is 2 plus 2 is 4, okay? It's not 2 plus 2 is about 3.8, okay? Because we're exact in math, we're going to find the exact value of log base 3 of 33. We're not going to estimate it. We're going to use that estimating knowledge that we learned yesterday to make sure that we're close in our answer, that we're in that where we should be. But we're going to use some calculations today to figure out exactly. Okay? And the calculations that we're going to use is this thing here called the change of base formula. Okay? Now it's in small print here. I'm going to scroll down here in a minute and I'm going to talk to you. I'm going to write it out better and figure out what it means in a better sense. Okay? The change of base formula is going to allow us to solve for any log. Okay? We can find the value of any log at any point in time. The calculators that you use are limited in their logarithmic knowledge. Okay? If you look at a scientific calculator, and side note before I say as you're digging out your calculators, which FYI you should be digging out your calculators right now. Whatever calculator you're using, use it. Meaning, all throughout this chapter, use your calculator so that you know how to use that calculator, so when it comes to the chapter test, you know how to use your calculator. Don't be switching from this type of calculator to that type of calculator to an Inspire to another type. Okay? Stick with one calculator and use that kind of calculator all the way through, because every calculator is different. Okay? And I'll show you what I mean by that when we get into it. Okay? But your calculators, your scientific calculators, are limited in that they have two logarithmic keys. They've got your log key and they've got your natural log key. Your log key on the calculator is going to be log base 10, your common logs, and that's it. Your natural log on the calculators is going to be log base E. And that's it. So you can only on your calculator do log base 10 problems and log base E problems, okay? Which is limited. Change of base formula allows your calculator to figure out any log. Okay? So, how the change of base formula works is we take log for instance, in a little bit, we're going to figure out log base 3 of 33, that problem that we did yesterday that we started with estimating. Okay? How this works is this is equal to, and you've got two choices here. Your first choice is it could be log of C divided by log of B using common logs, log base 10. Okay? Or, if you don't like using common logs, it could be the natural log. Oops, no, I don't like it. I gotta go back to this way. The natural log of C divided by the natural log of B. I keep forgetting to write my L's in cursive so that you don't get them confused with I's. Okay? It's not IN, it's not the word in. It's logarithm natural. Okay? It's LN. So we can do that in either case. And that allows us to figure it out. Now your TI Inspire calculators, the makers of those said, that's way too much stuff to remember. We're just going to let you type it in as you type it in. Okay? And I'll show you that method too if you are an Inspire type of user. Okay? So, log base 3 of 33. Yesterday we said that that was approximately 3.2. Okay? Now, how your calculator works is going to determine how you type it in. Okay? If you can see what you're typing in, if you can't see what you're typing in. If when you type in log, it opens up a set of parentheses. Or if you type in log, it doesn't open up a set of parentheses. All of that matters. Okay? So, if I am doing this, that means then that this is equal to the log of 33 divided by the log of 3. Or, that means that this is the natural log of 33 divided by the natural log of 3. Okay? Now, how you type that in is determinant upon your calculator. Some of the calculators I see out there don't have a spot to, or you don't see what you're typing in. Okay? So you're going to have to go 33 log, enter, or equals, divided by 3 log equals. Okay? Or 33 natural log equals divided by 3 natural log equals. What's up? You're using one or the other. They're two different buttons. You're using one or the other. You're either in the green category or you're in the red category.
What is there any difference?
How do you know if you're supposed to?
It doesn't matter. You're either in the green category or you're in the red category. It's a matter of personal preference. Which button on the calculator do you like to push, and which button do you not like to push? Okay? Tap the brakes, child. Tap the brakes. Okay? All right? Now, if you can see what you're typing in, okay, then you have to be careful. Because if you have a calculator that opens up a set of parentheses when you hit log, you have got to close that set of parentheses before you hit the divide sign, and then close that set of parentheses at the very end. Okay? Or you could go log of 33 and then hit equals, and then hit your divide, and then type in log of 3, and then hit equals again. And you can replace all of those with natural logs too. Okay. Either way, again, red or green, typing, you can see what you type in, you can't see what you type in. Okay. When you do this, okay, so you would make a fraction, or so you would go, actually here, let me go, so you would go log of 33 divided by log of 3, and you get that. That's one way of doing it. Okay? Another way of doing it, natural log of 33 divided by natural log of 3. It's the same answer. Okay? Now, if you are using an Inspire calculator, you can also just go log base 3 of 33, and it will give it to you automatically. Okay? They were smart and they said, well, let's take this change of base formula out of the way. Okay? So in either one of those methods, it works. So log base 3 of 33 is equal to 3.183. In answer to your question, Megan, now that I'm ready for it, we will be rounding to 3 decimal places. Okay? Questions on that? So, going back to last week, when we had the question 2 to the x power equals 10, and we didn't know what x was equal to, we can now answer that question, because now we can switch forms from exponential to logarithmic form. If I switch 5 to the x equals 36 from exponential form into logarithmic form, I get log base, what? 5 of 36 is equal to x. And now I can use my calculator and the change of base form to figure out what log base 5 of 36 is. I know from yesterday that it should be bigger than 2, because log base 5 of 25 is 2, and it should be smaller than 3, because log base 5 of 125 is 3, and I know that 36 falls between 25 and 125. Okay? So this would either be log of 36 divided by log of 5, or this would be natural log of 36 divided by natural log of 5. And in either case, I get x here equals 2.227. What I would like you to do now is I would like you to solve those next two. First, I got to change form, so this becomes log base 3 of 112 is equal to x. Using my change of base formula, that's either going to be log base 10 of 112 divided by log of 3, or that's going to be the natural log of 112 divided by the natural log of 3. In my brain, I know that this has to be bigger than 4, but smaller than 5. So x here is equal to 4.295. Okay. And this one, I changed the form. So this is going to be log base 15 of 4 is equal to x. So that's either going to be log of 4 divided by log of 15, or natural log of 4 divided by natural log of 15. And here I get x is equal to 0.512. Sensical-wise, that makes sense because 4 is between 15 and 1. Okay. Alternative logic-wise, that makes sense because an exponent of 1/2 put on 16 is equal to 4. 16 to the 1/2 power is the square root of 16, which is 4. Okay? 15 is really close to 16, so this should be really close to 1/2. Okay? What I would like you to do now is turn to your textbook to page 820, where Mark and Scotty were each asked to determine which base was used to estimate the value of log base b of 58 is equal to 2.9. Mark has his logic, Scotty has his logic. What I would like you and someone near to you right now is to tell me who between Mark and Scotty is correct. Okay? Go for it. With an explanation. Alright, so talk to me. Mark or Scotty? Ben, what do you got?
Mark is right. Well, they're both right that it falls between, like, they're the way to say it, they both fall between 2 and 3, but Mark had the right decimal instead.
Okay. Luke?
I was going to say Mark too.
Mark 2? Same rationale? Okay. Under Scotty's reasoning, so technically Scotty is right. Right? Okay. Technically he's right. Okay. What if Janet was also in that class, and Janet said log base, or the base has got to be 6? Would Janet be right too?
Is Mark right because it's split in the right place?
Yes.
Because it's
And it
58
would
is
also be right.
closer to
She has right down 2.2.
Hold on. So we'll say Janet here. Went with a base of 6, right? So log base 6 of 36 is 2. Log base b of 58, we said was 2.9. And log base 6 of 216 is 3. So would Janet be right with a base of 6?
Well, that'd be between 2 and 3, but
Is she right?
no,
Why not?
because her decimal would be 2.2.
Why is she not right?
She's got 2.9. She's got 2.9. Should be 2.2.
The question that's being asked is estimate the value of the base. Is she right?
Oh, yeah.
She's right still. Okay? What if Jenna said B is 7? Would Jenna still be right?
Yeah, barely. Yeah, look.
what if Eli said the base was 8? Why not? So it would, in Eli's, it would be between 1 and 2, right? So Eli would be wrong, but those other 4 would technically be right. Okay? Technically, they would be right. Who's the most accurate in their estimation? Mark is the most accurate. But technically, all 4 of them are right. Okay? But Mark is the most accurate of the 5. Okay? Right? What I would like you to do now is I would like you to find me the bases that make those 3 problems work. Alright, so I've seen a couple of different methods here. So I'll show you the couple of different methods that I've seen. Okay? So the first method would be to say, well, this is log base B of 108, and that's got to be 2.9. Okay? So 2.9 falls between 3 and 2. So I need a log with some kind of a base that has an exponent of 3 bigger than 108. Okay? So for me, that says 5 to the third is 125, which means then that this would be log base 5 of 25 there. Erase that. That looks goofy. And that falls in that range, right? And it's pretty accurate because 108 is a lot closer to 125 than it is to 25. So, and 2.9 is a lot closer to 3 than it is. So I would go with a base here of 5. Okay? I'm not looking for exact. I'm looking for you using question number 1 from yesterday, which was log base 2, log base 3, log base 4, and log base 5. Okay? Alright? So then down here, another way that I saw was saying that, well, if you use change of base formula, log base 7 or log of 74 divided by log of something has to be 3.1. Okay? And then you try different numbers. Okay? So you would try 6. Okay? You would try 5. You would try, you know what I mean? You try it until you get something that's close to 3.1. And there it should be, it's 4. Yeah. So B here is 4. Okay? Because if I put 4 into there, I get 3.1074-ish. And so that's pretty tight right there. Okay? Now, another method that I have seen is you could change this into the exponential form and go about trying to solve that. Okay? Okay? Not necessarily the easiest way to do it, this third method, but it's still a way. Okay? Back to my numbers. There they are. Okay? So then you could try different B values here. So if B was equal to 3, then you could try 3 to the negative 1.3 power. Okay? 3 to 0.2397. You could try b equals 4. And so that would be 4 to the negative 1.3 power, which is 0.1649, which I'm going the wrong way. I want to be at 0.4, so then I would try 2. And that would be 0.4061. And so then you could say here that your base then is 2. Okay? So you've got many different ways when you're trying to find the base to solve it. Okay? Tonight your homework is going to be the blue sheet, the 11.1. Since it is Wednesday and Friday is 2 days away, you have plenty of time to get it done and turn it in this week, Friday.